Alright, this is your review for your polynomial functions test. Our first question asks us to identify the number of solutions or zeros. Remember, this is the same as the degree or your highest exponent. So if we look at this, our highest exponent is an 8, so there are going to be 8 solutions. On our next one, we want to solve the equation. Well, we're going to have to factor this, so we want to move that 20 over. So I'm going to have y cubed minus 5y squared minus 4y plus 20 equals 0. And then it has 4 terms, so I can factor this with grouping. So I'm going to look at my first 2 terms, and I'm going to see what can I factor out of those. So I can take out a y squared, and if I take that y squared out, I'd be left with y minus 5. And then negative 4 and 20, so I can take out a negative 4. And I'm choosing a negative 4 because I have a negative right here. And when I take that negative 4 out, I'll have y minus 5. So then both of these have a y minus 5. And the other factor is y squared minus 4. Now y squared minus 4 has 2 terms, it's squared, and it's a difference of squares because I can square y to get y and square 4 to get, square 2 to get 4. So this could be factored again to be y minus 5 is times y minus 2 and y plus 2. So then my solutions are y can be 5, can be 2, or it can be negative 2. Number 3. I'm going to get everything on the same side, so I have s to the 4th minus 15s squared plus 54 equals 0. And my numbers that multiply to give me 54 and add to give me negative 15 are a negative 6 and a negative 9. So when I factor this, I'm going to have s squared. And I have s squared because this right here is that s to the 4th, and my middle term is s squared. So this has to be, instead of just an s squared. So I have s squared minus 6 and s squared minus 9. So again, I have 2 factors that they have the s squared. They're both differences, but 6 is not a perfect square. 9 is. I can square 3 to get 9. So s squared minus 6 won't factor anymore, but s squared minus 9 will factor to be s minus 3 and s plus 3. So then I can set my factors equal to 0 and solve. So s squared minus 6 is equal to 0. S minus 3 is going to be a positive 3. S plus 3 equals 0 will give us a negative 3 for our answer. S squared minus 6. I need to add 6 to both sides, so I get s squared is equal to 6. Take the square root. S is equal to plus or minus the square root of 6. Plus or minus the square root of 6. So these, all 4 of these are solutions to number 3. Number 4. I can factor out an a, so I'd have a times a squared minus 9a plus 20 equals 0. Numbers that multiply to give me 20 and add to give me negative 9 are negative 4 and a negative 5. So I'm going to have a minus 4, and a minus 5. So I can set my factors equal to 0 and solve them. So a equals 0, a is equal to 4, and a is equal to 5. Those are my solutions for number 4. Number 5, write a polynomial function of least degree that has a leading coefficient of 1 and the given zeros. So negative 7, negative 5, and 3. So that means that I have the factors of x plus 7, x plus 5, and x minus 3. I need to multiply any 2 of these. Y equals this. X times x is x squared, x times negative 3 is negative 3x, 5x, and negative 15. When I combine those, I'm going to have x plus 7 times x squared plus 2x minus 15. Now I need to multiply everything by x and by 7, so that gives me x cubed plus 2x squared minus 15x plus 7x squared plus 14x. 7 times negative 15 is negative 105. Combine like terms, I get x cubed plus 9x squared minus x minus 105. That's y equals that. That is my function. On my next one, I have negative 3, 7 plus root 7. I also have to have its conjugate 7 minus root 7. So I'm going to start off with x plus 3, x minus 7 plus root 7, and x minus 7 minus root 7. And whenever I distribute out that negative, I'll have x plus 3, x minus 7 minus root 7, x minus 7 plus root 7. So x times x is x squared. X times negative 7 is a negative 7x. X times positive root 7 is a positive x root 7. Negative 7 times x is negative 7x. Negative 7 times negative 7 is a positive 49. And negative 7 times a positive root 7 is a negative 7 root 7. Negative root 7 times x is a negative x root 7. Negative root 7 times negative 7 is a positive 7 root 7. And negative root 7 times a positive root 7 is going to be a negative square root of 49. And the square root of 49 is 7. So these will cancel and these will cancel. I'll have x squared minus 14x plus, and 49 minus 7 is 42. I still need to multiply this by that x plus 3. So when I do that, I'll get x cubed minus 14x squared plus 42x, 3x squared minus 42x. 3 times 42 is 126. So it's going to be a positive 126. So that gives me x cubed minus 11x squared plus 126. That is my function. Our next one, we're going to write the function, same thing, but I've got a 2 minus, or sorry, I skipped number 7. Find all zeros of the polynomial function. So this is a 4th degree, so I know there's going to be 4 solutions. Looking at it, it cannot be factored. I've got 5 terms, so I'm going to have to look at my possible zeros. So negative 80. I can get negative 80 with 1 and 80, 2 and 40. 3 doesn't go, 4 and 20, 5 and 16. 6 doesn't go because 3 doesn't. 7, no. 8 and 10. And those are my factors. And they can all be positive or negative. Alright. So I'm going to work this right down here. So I'm using synthetic division. I'm going to start off with 1. And right here I've got 1, 1, negative 16, 4, and negative 80. So drop this, multiply up, add down, multiply up, add down, multiply up, add down, multiply up, and negative 90. So it's not 1, try negative 1. Got 1, 1, negative 16, 4, negative 80. 1, negative 1, 0, 0, negative 16, positive 16, 4 and 16 is 20, negative 20, negative 100. That's not going to work. Try 2. 2, 3, 6, negative 10, negative 20, 4 plus negative 20 is negative 16, negative 32, nope, not 0. Try negative 2, try 4. And 4 works. So we have one solution. From there, I can work with x cubed plus 5x squared plus 4x plus 20. I can try to factor that if I want, or I can start this again with these factors, okay? So instead of looking at 80 and 40 and even 16, I can look at 1, 10, 2, 4, 5, and 8. Now I've already tried 1 and 2. If those were going to work, those would already work. I'm going to try this again with 4. Doesn't work. I'm going to try negative 4. Then I'm going to move on to 5. It's not going to work. Negative 5. Negative 5 works. So I now have 4 and negative 5. I know I'm going to have 4 solutions. I've already found 2 of those. Then I'm going to look at what I've got. So what I've got left, I've got 1x squared plus 4 equals 0. X squared plus 4 equals 0. Now I can solve this using square roots. I can subtract 4 from both sides. So x squared is equal to negative 4. Take the square root. X is equal to plus or minus, and the square root of negative 4, it's a negative, so I'm going to have an I. Square root of 4 is 2. So positive and negative 2i. And those are all of my solutions. Then I'm going to work on number 8. Number 8 wants us to write a polynomial function again. So here I've got negative 5, 2 minus 2i. I'm also going to have 2 plus 2i. So my factors are going to be x plus 5, x minus 2 minus 2i, and x minus 2 plus 2i. Again, I'm going to distribute that negative, so I've got x minus 2 plus 2i and x minus 2 minus 2i. And I'm going to multiply these second ones first, so x squared, negative 2x, negative 2xi, negative 2 times x is negative 2x, positive 4, positive 4i, positive 2xi, negative 4i, and 2i times negative 2i would be a negative 4i squared. But remember that I squared is equal to negative 1, so negative 1 times negative 4 is a positive 4. Combine my like terms. I still have this x plus 5 out front, and now I've got x squared minus 4x plus 4. Or sorry, plus 8. Misspoke. Now I'm going to multiply these, so I get x cubed minus 4x squared plus 8x. Then I have 5x squared minus 20x plus 40. Combine my like terms, x cubed plus x squared minus 12x plus 40. And y equals that. There it is, my function. Alright. Describe the transformation and then graph these. X to the fourth and x plus 4 to the fourth. So this one would have moved left 4. And remember, your x to the fourth goes through 0, 0, 1, 1, and negative 1, 1, and then it would go through 2, 16, which is off of most graphs. It grows very quickly. And then if we just moved it left 4. So instead of this being at 0, it would be at negative 4. X cubed, and then x plus 4 cubed plus 2. So we know this goes left 4, and it also has moved up 2. So our cubic function goes through 0, 0, 1, 1, negative 1, negative 1. It also goes through 2, 8, and negative 2, 8, and looks like this. So it would be this whole function moved left 4 and up 2. X cubed and negative 3x cubed. So our negative is going to be an x-axis reflection, and our 3 is going to be a vertical stretch of 3. So from this one, we would multiply all of our y values by negative 3. So instead of going over 1 and up 1, it would go over 1 and down 3. Instead of going down left 1 and down 1, it would go left 1 and up 3. So it would be reflected over, and I've multiplied those y values by 3 also. X to the 5th, 1/5, x plus 3 to the 5th. So this is going to move left 3, and it has a vertical compression of 1/5. So everything's gonna move left 3, and then instead of going over 1 and up 1, it would go over 1 and up 1/5. And x to the 5th would go through 2, and 2 to the 5th is 32. So instead of going over 2 and up 32, it only go up 1/5 of that far. So over 2 and up about 6. You can use your calculator on this, so I would most definitely use the calculator to see what that graph should be, and use your table so you have those exact values if you're graphing. Write a rule for G that represents the indicated transformations of the graph of the function. So 5x minus 3 translated 2 units right, followed by a reflection in the x-axis. Okay, so x-axis means that everything is going to switch signs. So it'd be a negative, this would become negative, this would become positive. And if it's going to go 2 units right, I'm going to subtract 2 from every x. So I'll have negative x minus 2 to the 5th plus 3. Now I don't do anything to 3 because it doesn't have an x with it. Our next one, we have a vertical stretch by a factor of 4, followed by a translation 2 units left. Okay, so I'm going to multiply all of these numbers by 4, so I'd have 12, and then I'm going to add 2 to my x value. So I'm going to have x plus 2 to the 5th, plus, and 4 times 4 is 16, x plus 2 squared, plus, and 4 times 6 is 24. G of x equals this, g of x equals this. Graph the function. You can graph this with your calculator. You can graph it with points by saying, okay, this is going to go through, this is going to have x-intercepts at 1, and it's going to have a double at negative 2. So I know it is positive leading coefficient, and it's a cubic function because this is squared factor and then that factor, so it's going to go up on the right and down on the left, and because this negative 2 is the double, it'll look something like this. You can get a more accurate graph just typing these into your calculator. 16 is going to go through 1, negative 1, and it's going to have a double at 4. This is a even degree, and leading coefficient is still positive, so I know it's going to go up on the right. Because it has a double at 4, it's going to touch there, it's going to cross at 1, and going to cross at negative 1, so it'll look something like this. 17, definitely want to graph that one, just go into y equals, typing it in. 18, determine whether a function is even, odd, or neither. Remember, if it is even, that f of x is the same as f of negative x. So look at g of negative x. So 2 times negative x to the 7th minus 3 times the negative x. Negative x to the 7th, okay, it's an odd power, so it's going to come out negative. So, because negative times a negative is positive, another one's a negative, positive, negative, positive, negative. So negative 2x to the 7th. Negative times negative is a positive. These are not exactly the same, so it's not even. Now, if that's the same as negative g of x, then it will be odd. Well, negative g of x is if I just switch signs. So negative 2x to the 7th plus 3x. These are the same, so it is odd. You could also type this into your calculator. Flip your calculator upside down. If it looks the same, it's odd. If it has y-axis symmetry, it is even. Negative 2x to the 7th, same thing. So I'm going to look at h of negative x. So I've got negative 2 times negative x to the 7th minus 7 times negative x cubed plus 7 times negative x. Negative to a odd power is a negative, but times this negative out front is going to be an even. So positive 2x to the 7th. Again, negative and odd power is negative, times this is going to give me a positive and a negative. Not the same. However, it is the same as negative h of x if I just switch these signs. So that means that this one is also odd. If I typed them in, flipped my calculator over, they would look identical. That's another way of seeing if it's odd or not. Write a cubic who passes through the given points, okay? So we have our x-intercepts at negative 1, positive 1, and 3. So we know that we can write this as y is equal to some value a, x plus 1, x minus 1, and x minus 3. And I've got this other point, 0, 3, that I can plug in for x and y. So 3 is equal to a 0 plus 1, 0 minus 1, and 0 minus 3. So 3 is equal to, that's 1, negative 1, and negative 3. A is equal to 3a. Sorry, 3 is equal to 3a, and divide by 3, a is equal to 1. So my function right here is y is equal to 1, x plus 1, x minus 1, and x minus 3.